Alright, so before we start, I'm gonna send you the tutorial worksheet I made. I'll send it in the chat so that everyone can use it. Alright, so that is the tutorial worksheet. And let me share my screen. Okay, while I share my screen, oops, I don't even have a copy of my tutorial worksheet. Okay, so while I try to do that, let me just introduce myself a little bit. My name is Lei Ying. This is tutorial 9101, but it doesn't really matter which tutorial you're in since the other TA is really good as well. So if you can't get up so early, you can attend the other tutorial. Anyway, I graduated last year in April, and I finished a double major in math and chemistry and also a minor in biology. So wait, this is why does it say 244 tutorial 1? Sorry, I'll fix it. Yeah, so 244 is the other course I'm TAing. That's why it says 244, but it should be 236. It's letting you know you're not in the wrong course. It should be 236. Okay. And I'm also TAing the other course, which is MAT236, Classic Geometry. If you're interested, you can thinking about taking that course as well. Anyway, that's about me. Now let's get to know you guys a little bit more. So type in the chat. What I want to know is, are you a math major? So what is your major? CS and math. Okay, nice. Stats and math major, economics minor. Okay. Seems like a lot of people like to combine economics with MCS. Math and stats. Okay, cool. So suppose math major minor in stats and CS, stats specialist, math and computer science minor. Okay, so everyone here is either doing a minor or a major. That's good. All right. My second question is, when did you take Math 232? Multivariable calculus? Last semester. So you had Andy? Last year? Yeah, okay, cool. Okay. So I suppose everything is still fresh in you. I'm not sure what you covered in 232 because every semester they cover different things. I mean, they're covering the same thing, but like the pace is pretty different. So for the people who took it last semester, where did you guys end it? Green theory and curl. Oh wow, okay. So did you guys do double integral? Did you guys do this chapter specifically? Chapter 15? Because I know we're using the same book. Okay, so everything today is just review for you. That's great. Okay, cool. Yeah, I was worried that people took this multivariable calculus a long time ago. Because for me, I took multivariable calculus during the summer, like the summer that I just finished my first year. So it was a long time ago. It's like I don't really remember anything. Anyway, so for today's tutorial, my top two topics. One is we'll go over double integral over rectangles, and we'll talk about double integrals over general regions. I checked your lecture notes. Your couple only started this, so will not be go ahead of your lecture. So I will stop wherever he stopped. So that's the plan. Now just review. So first tutorial is just chilling. Um, Also, since it's review, I hope everyone can be active since you know the material very well already. Okay, so double integral over rectangles. This is a definition. So the double integral f over the rectangle r is this, which can be computed using limit where m and n goes to infinity, and then we have the summation of 1 to m and 1 to n, and this and this. So for those of you who forgot what those are, this is your, what is this called? Anyone remember? So tell me, what is this point and what is this? It's just a review from 232. Anyone remember? Matrix. This is not the matrix. This is points, okay? This is called our sample points. Sample points. And this is called the area of each of my square. Okay, well, you don't need to know what they're called, but as long as you know what they actually are, then it's okay. So, let's look at this graph. Okay, if you look at this graph, each of the points, so this point, this point on this surface, okay, each of those points is your sample point, which is a point you pick to compute your integral. Or in this case, we're computing the volume of this solid. Okay, so each of this point is for you to compute that. And this sample point, you can pick it to either be the middle point, you can pick, you can let it be the upper right corner point, lower left corner point, and whatever you want. Okay, that is why we have star here, because well, this sample point, you don't know what it is yet. You need to let it be something. And also, if your fxy is greater than or equal to 0, then the volume of the solid, which is what we see here, okay, this volume lies above the rectangle r, which is this. This is your r. And then below this surface is your integral. Okay, so sometimes when we try to compute the integral, we can use Riemann's sum to make an estimation by calculating the volume. I suppose everyone remember that. That's why I didn't review the Riemann's sum thing. But it's basically this. Okay, so you divide each of the parts. Each of your width and length into different parts, where for x it's m parts and y is n parts, and you just add each of the volume together. Okay, I suppose everyone remember that, so not trying to do too much. The second one is called midpoint rule. Basically, what you're doing is, instead of taking, let's say, upper right corner to be your sample point, you're taking the middle point of each of the square to be your sample point. So that's why we use xi bar and yi bar. Okay, because those are the midpoint of those. Okay, so xi bar is a midpoint of xi minus 1 xi, and yj bar is a midpoint of yj minus 1 and yj. Anyway, let's do an example. So this is the first example. I will give you 5 minutes to try this and we'll take it up. During those 5 minutes, you can ask me any question if you have anything. But yeah, we'll take it up at 9:26. Okay. Again, anyone has any question, please let me know. You don't have to type in the chat, you can just unmute yourself and ask. It's easier for both of us. Upper right, what does upper right mean exactly? Okay, so basically, let me draw something and I'll tell you. So basically, if your xy coordinate is like this is just like Riemann sum, and let's say your x is from 0 to 1, 2, 3. So let's say 0 to 3. Y is from 0 to 2. Okay, and then your m, let's say m equals to 3, which means you divide this part by 3. So that's 1, 2, 3. And let's say your n is 2, so you divide your y into 2 parts. Then you have those squares or rectangles. Okay, so those are your squares. Each of those squares, upper right means that you pick your sample point to be the upper right, which is this. So for this square, you are picking this point to be your sample point. And for this, you pick the upper right point to be your sample point. So in this case, if you are using upper right corner, then you are using those points. Okay, so that's gonna be your x, I, y, j. So you use that. Sounds like confused. Well, that's what your textbook's using, so I'm just use whatever they're using. Do we give our answer? Are you talking about the question? Example? Sure, you can give us your answer and let's see. Okay, so what's your answer? Yeah, 288 for part A, right? Yeah, that's correct. And try part B.
Hey, I'm sorry. Can I ask a question?
Sure, go ahead.
Yeah. So, like for the formula, do we automatically assume that m is for the x and n is for the y?
Yes, yes.
Okay.
Okay, 144, that's correct as well. Okay, so let's try this. It's 9:26 already. So let's do this. I suppose everyone is really familiar, so let's do it slightly faster. I'm gonna draw my coordinates. Okay, so look at this. You see that our n is 3, n is 2, and our x is between 0 to 6, y is between 0 to 4. So let me draw this out. So let's say that's 2, 4, 6, and then 2, 4. Alright, so this, gonna draw my squares. Oops, looks kinda ugly. Okay, does not look like square, but just bear with my drawing. Alright, now we need the area of each square. So for our fxy is xy, which is our z here. And then the area of each square is 2 times 2 equals to 4. So you're looking at each of those square, okay? And now let's just compute it. So the volume equals to, not equal, it's around, approximately the sum from 1 to 3 and then 1 to 2, fxi yj delta a, which equals to, so for each term we always have delta a. I'm gonna factor it out, which is 4 times. Now, since we're taking the upper right corner of each square as your sample point, so that means we're taking those points to be our sample points. Alright, so that means we have f22 plus f42 plus f62 plus f24 f44 and then f64, and you just compute them out. That's gonna give you 4 times 4 plus 8 plus 12 plus 8 plus 16 plus 24, and this will give you 288. Alright, so that's part A. Part B, they ask you to use a midpoint instead of upper right corner. So let's change the graph a little bit. So this time, instead of having,
Sorry, we can't see your screen.
oh, sorry, I don't know what happened. Can you see it now? Okay, cool. Then let me go back a little bit. Okay, so that's part A. Part B, you are picking middle point instead of upper right corner. So midpoint would be here, 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 those points. Okay, and the area of each square is the same, so our delta A is still 4. Now our volume is around, again you're adding from 1 to 3 and 1 to 2, fxi bar and yj bar delta a. Okay, bar means you are taking the midpoint, the average value. So this equals to 4 times f11 plus f31 plus f51 plus f13 33 53, which will give you 4 times 1 plus 3 plus 5 plus 3 plus 9 plus 15, which will give you 144. Okay, any question? Okay, if no question, send me your favorite emoji in the chat so that I know I can move on. Okay, cool. So that means we have no question. Next example. Okay. Again, I'll give you some time to work on this and I'll take it up. It's basically the same thing, but with a little bit application. Let's see if you know how to set it up, right? We'll take it up at 9:37. Yeah. Yeah, that's why it's application because you are measuring the depth of the water. So basically it's impossible to say, well, between 0 and 5 it's something. Does that make sense? So they can only measure at a certain point. So at certain let's say 0, 0, what is it? Well, at 0, 0 it's 2, right? It's 2 feet. So that means at 0, 0 it's 2 feet. At let's say 0, 5 it's 2 feet. At 0, 10 it's 2 feet. Okay, like that. No. Yeah, that's why it's application question. That's why we did an example like this, and I'm giving you another one because this is like you need to understand what's going on. And also you need to pick your sample point wisely because if you pick, let's say, something, then you don't have any value to compute. Okay, so you need to pick your sample point wisely. Alright, let's take it up. So, basically, it's the same thing, except we need to set it up mathematically. So, what I'm gonna do is first I'm gonna set it up. So, let me let R be the planar region corresponding to the surface of water in a pool. And then let's place R in the coordinate axis in which our x and y corresponding to oops, correspond to the dimension given above. And now let's define our fxy. Now let's define our fxy to be the depth of the water at xy. Okay, then our volume, the volume of water is the volume of the solid.
I'm sorry, we can't see your screen again.
I don't know what's going on today. Sorry about that. Okay, there we go. Okay, just unmute yourself and let me know, because when I write, I don't really check your chat. Where am I? Then the volume of water is the volume of the solid lies below. So below our fxy and above our rectangle R. Okay, so now let's pick our M and N. If you want to be more accurate, then you can pick M and N such that you use each of the points. But if you want to be lazy, you can pick smaller M and N. I'm gonna be more accurate, so let's pick M before and N equals to 6. So let me draw the graph here. In that case, I'm gonna have something like this. 1, 2, 3, 4. 1, 2, 3, 4, 5. Get longer. 6. Okay, then my graph is gonna be something like this. So it's not a good graph, but you know what I mean. Whatever. It's not perfect, but you know what I mean. Okay, it's really uneven, but yeah. Okay, and then I want my sample point be, let's say, upper right. upper right corner. The reason I choose this is that I know that I cannot choose midpoint because from what I'm doing here, so that's 20, that's 30. From what I'm doing here, if I pick midpoint, then I don't know what my xy is because I only know those points. Okay, I only know the volume, I mean the value of f of xy at the corners. So you can only pick the corners to be your sample point. And let's compute this. So upper right points will be those. Okay. Should have picked the smaller m and then it's a lot of work. Anyway, do we need to do all the setup? I'm not sure what your professor's standard is, but it's better that you do. But sometimes we don't care that much. Yes, I know the mathematical setup. It's better that you do, but sometimes we don't care that much. And I'm not sure what your professor think. Because they haven't emailed me yet. So we'll see. Anyway, the this part is the most important part, so make sure you know this first. Okay, so since I picked that, my delta A would be 5 times 5, which is 25. And my volume would be sum from 1 to 4 and then 1 to 5. And then fxi yj delta A, which equals to 25 times. Okay, now look at each of the points. So 5, 5. So we need 5, 5, 5, 10, and so on. So we need all those points. So you're adding all of those together. Okay? So the points are highlighted, you're adding them together. So that's gonna be 3 plus 4 plus 7 plus 8 plus 10 plus 8. 4, 6, 8, 10, 12, 10, 3, 4, 5, 6, 8, 7, 2, 2, 2, 3, 4, 4. Okay, and this will give you 25 times 140, which is 3,500. Okay. If you see questions like this on a test, then I suggest you, if they didn't tell you what M and N to pick, then I suggest you to pick smaller ones. So for example, pick M equals to 2, N equals to 3, then this will be much easier. Okay. So for a test, if they didn't tell you, then you just to save yourself some time, you should pick smaller, well, smaller value of an M and N. Anyway, any question? Okay, if no question, let's type in the chat your favorite color. Oh, my favorite color is green as well. Although I'm not using any green here because I realize that green is not that popular among my students because I asked the same question in my other tutorials. Most people like blue, so well, I'm not using blue either. But anyway, it's like kind of blue and purple, dark blue and purple. Anyway, no question. Then let's continue. So the next one is Fubini's theorem. Basically this you can switch around. Okay, so you can first do this and then do the x, and you can first do this and then this if f is continuous. All right, so let's use this theory and try example 3. So this example was a test question from last year. Was that last year? 2019, so 2 years ago because it's 2021 already. Alright, so guys, try example 3. Anyone have an answer? Let me see. The final answer. Yeah. If you're done, type your final answer in the chat. Or if you are not done, you want me to take it up, then type your favorite number in the chat. Seems like we won't have enough time to do another example. Okay, I suppose your favorite number is pi. Alright, let's take it up then. So basically, they ask you to compute it by changing the order of integration. So right now we're integrating with respect to x first. So they want you to change it, so you want to integrate with respect to y. So to do that, you need to change those as well. So let's find out what is our x from. So let me draw the graph. Hey, my favorite number is 2 and 9, by the way. For single digits, I have another favorite number for two digits number. But generally speaking, I like all numbers with 2 and 9. So our y is from 0 to 2, and our x is from 0 to 1 minus y over 2. So this x equals to 1 minus y over 2 is a straight line. So you just need to find 2 points. Let's say when y equals to 0, our x is 1. When y equals to 2, our x is 0. So this is our graph, okay? This is x, y. So if you want to change the order of integration, it's x is from 0 to 1, and y is from 0 to a function. So I'm gonna write this uh, as y equals to something. So this will give us 1 minus x equals to y over 2, which means our y equals to 2 times 1 minus x. That means our y is from 0 to 2 times 1 minus x. Then we have e to the power of 2x minus x squared dy dx. Alright, so the rest is just computation. So this equals to 0 to 1, and then e to the 2x minus x squared y, and then you have y equals to 2 times 1 minus x, and then 0 dx. That's gonna give you 0 to 1, and then 2x minus 1, no, 1 minus x, sorry, e to the 2x minus x squared dx, which equals to e to the 2x minus x squared goes from 0 to 1, and that's gonna give you e minus 1. Okay, that's it. Any question? Can I move on? Anyone has any question? Okay, I suppose no question because everyone's super quiet. Alright, so for example 4, I'm only gonna set it up and you guys can do the computation yourself because we're running out of time. Alright, so basically, this volume, if you look at this, enclosed by the paraboloid and plane z equals to 1, x equals to 1, x equals to negative. So basically, if I draw it out, uh, okay, so x is between negative 1 to 1, y is between 0 to 4. Okay, so your xy plane is gonna be something like this. Okay, so from negative 1 to 1 and 0 to 4. And then it's gonna be above z equals to 1 and this. So basically, this volume, the volume of the solid is actually the difference between the solid lies under z equals to 2 plus x squared plus y minus 2 squared over the rectangle r, which is negative 1 1 times 0 4. So we know how to compute this solid, right? So it's just this surface and this is your rectangle. So we know how to compute this. And to compute this volume, it's this minus and the solid lies under z equals to 1 and r over r. So you want to remove the part that's below z equals to 1. So you want to remove, this solid. Okay, so you want to remove this solid. You only want the upper part. So the setup is gonna be this. And I'm pretty sure you can do the rest yourself. So let's just write down the setup. 2 plus x squared plus y minus 2 squared dx dy minus, again, 0 to 4, negative 1 to 1, and this one is 1 dx dy. Alright, so that's example 4. Any question? You can do the rest yourself. I'm pretty sure you can do that yourself. I'm gonna go slightly over time. Just talk about a little bit of double integral over general region, which you guys probably know already. So in this case, we have general region instead of rectangle. We have general region like this. So the function you're gonna use is big capital F x y, which is a piecewise function where it equals to fxy if it's in D, and it's 0 if it's not in D but in R. So to do this, we have two types of region. Type 1 region is that your graph lines between graph of two continuous function of x. So something like this. Okay? Two continuous function. So those are continuous function. Oh my, what happened? Okay. Anyway, that's type 1 region, and I gave you the formula here that you can use. And then type 2 region is exactly the opposite of that. So it's it's in between those two continuous graph. That's called type 2 region, and this is a formula to calculate it. I briefly talked about this because your lecture hasn't covered all of those yet, but next week we'll do examples on this session. That's the end of the tutorial, so bye everyone, have a good week. Well, if you just came in, welcome to my tutorial. Bye.